This is Chapter 9 for the exam review for Semester 2. Looking for the distance. x2 minus x1, y2 minus y1. That's a distance formula. So we can call that x2, x1, y2, y1. 2 plus 5, 7 squared is 49. 9 minus 8 is 1 squared is 1. $25 and 2 make 50, so it's 5 root 2. That's the distance. The midpoint is x1 plus x2, y1 plus y2. So we get negative 3 over 2. And we get 17 over 7. 17 over 2. x1 minus x2. It doesn't matter if you do x1 minus x2 or x2 minus x1, you just need to be consistent throughout the problem. I started with this side first, so I have to start with this y first. Negative 14 squared, negative 15 squared, adding those two together would be 421. So it looks like the distance is the square root of 421. Doesn't seem like that can be broken down. Then the midpoint would be your x plus your x and your y plus your y. So negative 2 divided by 2 is negative 1. Negative 9 divided by 2 is 9 halves. For the second problem of Chapter 9, we're trying to find the focus of the parabola. So this looks like it's in the form of y squared equals 4px. So negative 36 equals 4p. So p equals negative 9. Making a small sketch, y squared is going to open up sideways, so we know the focus is going to be 9 units to the left. So the focus is going to be at negative 9, 0. This parabola starts with x squared, 4py. So we say that the 4p equals 100, so p equals 25. Because x is squared, we know it opens up. So in this case, it would have to be 0, 25. Because the parabola hugs the focus. Number 3, write a standard form of an equation of a parabola. We know that the center is at 0, 0. Center's here, which is the vertex. We have a directrix at -7. That means we have a focus at +7. That means this problem is y squared equals 4px. The p is 7, so we're going to have y squared equals 4 times 7, which is 28. It's positive, which means it opens to the right or up. It's squared, y is squared, so that means it definitely opens up to the right. Here, making a sketch, we know we have a focus point at 0, -5. So that means the P is -5. So using our format of, if the focus is down, we know it has to curve this way, and it has to be an x squared equals 4py. So x squared equals 4 times -5y. So x squared equals -20y. Write the standard form of an equation of the circle. The radius is 14, and the center, which is HK, is going to be -5, 7. There's two parts that we need to know to write an equation of a circle, and that would be the radius and the center. So we can go right into our equation now, which is x minus h squared plus y minus k squared. So we have x minus a -5 and y minus 7. So we have 196, x plus 5, y minus 7. And both quantities are squared. What are the foci of the hyperbola with this equation? Well, a hyperbola is going to be two curves going in opposite directions. We can divide by 225. And when we divide, the reason we do that is because we want it to equal 1. Now we know our a squared equals 25 and the b squared equals 9. So the foci are your two focuses that are a distance of c away from the center point. So we could take a squared plus b squared equals c squared. So c is going to be a plus or minus square root of 37. Now, because we have y squared first, we know our hyperbola is going to follow the y, because y squared is first. The 25 tells us it's going to be 5 until you get up to each vertex. The 9 tells you it's going to be 3 till you get off to the sides, which makes the box, and connect your diagonals together. So our focus points, foci, are going to be at either end, so that's 0, comma, plus or minus the square root of 34. we're going to write an equation in the standard form of an ellipse. We know what the foci both are. We know what the vertices are to write the equation. To write the equation, we need to know what the center is. We see that the halfway point here is 0, so at 0, 0 is the center. We need to know what the a squared is. That's the distance to the vertices. That's a, so a squared is 36. What we don't know is the b. We know that the c value is 3. We know the a value is 6. So a squared minus b squared equals c squared. We would have 27. It would be a negative 27 divided by the negative. So our distance is going to be the square root of 27, which can be broken down into 9 times 3. Square root of 9 is 3, so we'd have 3 root 3. But anyway, 27 is the main number we're interested in. To write an equation of an ellipse, we always put the x first and the y second. There's always a plus in between. Now, because the vertices are going right and left, 6, 0 means you go to the right. 0, negative 6, 0 means you go to the left. The foci are also less than that. You now have your b value, which is up a short distance. So you notice it's going sideways. So your a value is, of course, following the x. So we have 36 here, and we have 27 underneath the y squared. To graph this equation, we notice that it's an x squared plus a y squared. Because the coefficients in front of each of the squares are different numbers, we know that this is going to be an ellipse. If they were exactly the same, we'd know that it would be a circle. So we'll divide by 100. X squared over 4, y squared over 25, and 1. Because to write the equation of an ellipse, it has to equal 1. The larger number is called your a, or a squared. Your smaller number is your b squared. So, because there's no parentheses here, there's no hk, that means the center's at 0, 0. We'll follow 5 units with the y-axis. Two units with the x-axis. And then to find your focus point, a squared minus b squared equals c squared. We use the equation with the minus when your ellipse always has a plus. A squared is 25, b squared is 4. So the square root of 21, which is, let's see, 5 times 5 is 25, 4 and 4 is 16, so it's somewhere between 4 and 5. So your focus point is towards your vertex, halfway between 4 and 5. Then we always like to write our equation. Graph and identify the radius of the circle with a circle. Notice this time we have the plus, so it's kind of like an ellipse, but both of the coefficients are 4s. Leading coefficients are 4s. So we're looking at x squared plus y squared equals 25. So x squared plus y squared equals 5 squared, because the equation is r squared. So 5 up, 5 to the side. So there's our circle, and our radius is 5. Write the equation of an ellipse with the vertices of 0, negative 6, the co-vertices negative 4 and 4, to write our equation, we need to know what the center is. Well, the center is at 0, 0, because it's halfway between. The a value is the distance to the vertices, which is 6, so a squared is 36. The b value is the distance to the co-vertices, so b squared equals 16. And that's actually all we need to know. We don't even need to know the c value. So we have x squared plus y squared equals 1. Now, because the vertex is following the y value, we know that the a value has to follow the y. To write the equation, we do not need the c value. To graph it, we would use it. And if we're going to graph this out, then we would say a squared minus b squared equals c squared. So c is the square root of 20, which is more than 4 but less than 5. And those would be your c values. So it's always a good habit to write your equation. X squared over 16 plus y squared over 36. And back in this one, we would say x squared plus y squared equals 25. On our next page, number 10, we're looking at another equation to graph. It has a minus in between the x squared, y squared, so we know that this is a hyperbola. We know that the x and the y would change orders. This is your a, actually your a squared, and your b squared is 36. In a hyperbola, the a is not always the larger number. So the x shows that the a value is going to be going to the right and to the left. The 6 is not part of the actual graph of the hyperbola, but it is there to help us identify the asymptotes that the graph is going to approach when it opens up. Because the x squared is first, we know that it opens up sideways following the x-axis and following, it's hugging the x-axis and it's following these asymptotes. And our equation is x squared over 4 plus y squared over 36 equals 1. You should also plug in the foci. Because the hyperbola has a minus, this equation has the plus. The a value is 4. The b value, the a squared was 4. The b squared is 36. So we know that 6 times 6 is 36. So we know that this is more than 6, but less than 7. This next shape here, it's x squared, but there's only one type of variable that is squared. So we know it's a parabola. It's x squared. The 4 is positive. So we know it opens up. The center's at 0, 0. The normal format would be like that, so we know our 4p has to equal this 4 value, so p has to equal 1, which means that it's 1 unit to get to the focus point and 1 unit to get to the directrix. Then we would start to plug in some points. We can pick some values for the y. So if we pick 0 for the y, that has to be 0. We pick 1 for the y, that's 4. The square root of 4 is plus or minus 2. 8 would be plus or minus the square root of 8. We plug in a 3, which is 12, plus or minus the square root of 12. So at 0, we're at 0. 1 over. When the y is 1, we're over 2, our table says. When our y value is 2, we're over the square root of 8, which is a little less than 3. And then when our y value is 3, we're over more than 3 but less than 4. And then of course if this was 4, then that would be 16. We'd be at plus or minus 4. So our graph seems to be following that curve right around. Our equation is x squared equals 4y. To graph another parabola, we see that this one is y squared, so it's going to open up sideways. The negative 12 means it's going to open up to the left. The 4p has to be negative 12. So the p is negative 3. The directrix is going to be at x equals 3. Make our table for the points. Now we want to pick values of x and then take the square root of them for our y. So at 0 would be at 0. And we know that we have to use a negative value. because the graph does not exist to a positive x. So the square root of 12, square root of 24, square root of 36. So when x is negative 1, we're at more than 3 but less than 4. At 2, we're just less than 5. And then at negative 3 for x, we're just less than 6. Or we're right at 6, actually. So notice how the parabola is the only one we made the graph for. But we write the equation for all our graphs. Last question. Classify the conic sections as a circle, an ellipse, a hyperbola, or parabola. We're going to have to manipulate this guy around here some. We would add the 25 over. We would divide by the 1600 so it equals 1, and you would see that this would have to be an ellipse. In this case, we'd have to subtract the y squared over. We would divide by the 1296 so we can have a value of 1, which means that this would have to be a hyperbola because there's a minus in between the x squared, y squared. We'll add over the 8y squared. We would add over the 192. Notice how the x squared, y squared have the same coefficient, which when you divide it, it would indicate that this was a circle. And here we have just one of the variables that are squared, which tells us it's a parabola.